Hello everyone. Today we will be discussing this problem maximum cost deletion from educational code forces round 111. So this problem goes like this. We are given a string of zeros and ones, and we have to convert this string to length 0. And how are the operations done? We have to choose a substring such that the consecutive digits of that substring are same. It can be 0 or it can be 1, and the points that we score in deleting that substring is a into length plus b. So a and b are given in our input, and the problem question is given in the description. So the explanation for this question goes like this. First we need to actually take a look at a into l plus b carefully. So consider a string 1 0. There can be two cases in which we can delete this substring and convert it to length 0. The first one is we delete one digit after the other, in which case the point scored in the first step will be a into 1 plus b, and the point scored in step 2 will be a into 1 plus b. And the second case is if we delete both the digits simultaneously, so the point scored in that would be a into 2 plus b. Now as we can see that a into l part in our final sum is not depending on how we take our steps, so it will always be equal to a into n, that is our length of the string. So what we need to take care of is how we make our steps to maximize or minimize b. So we just need to take care of the b part. So we are just left with two cases, that is when b is either greater than or equal to 0 or b is less than 0. If b is greater than or equal to 0, we need to maximize our number of operations, because in each operation b would be added, and if b is greater than or equal to 0, we need to maximize our number of operations, and vice versa for the case when b is less than 0. So let's take the example that is given in our question. So this string is given 11001 and a is -2, b is 5. So this is an example of case 1, that is when b is greater than or equal to 0. Thus we need to maximize our operations to get so that b is added more number of times in our sum. So what we can do is we can actually delete each digit one by one. So in our sum the b part would actually contribute to 5 times. That is, we can see that a part is contributing to the length of the string that does not depend on our operations, and the b part is actually contributing 5 times, so our sum is 15. So let's take another example that is given in the question. It is 10011 and a is 1, b is -4. So in this case we need to minimize our operations. Why? Because this is an example of case 2, that is when b is less than 0. So how can we minimize our number of operations? We can't actually delete the complete string in one step, because it is actually consisting of ones and zeros we just need to delete those parts that are consecutively same. That is, we can either delete a 0 part or a 1 part. So we need to actually count the number of 0 parts and 1 parts in our string. So as we can see, there are 2 1 parts in our string and 1 0 part. So in the first step what we can do is we can delete the 0 part so that 1 parts are combined, and then we can delete the complete 1 part. So How have we calculated? We take the minimum of both the parts and we add it and a 1, and finally we get our sum to be the sum of a part and the b part. A part is, that is 1 into 6, 6 is the length of our string, and 2 into minus 4. 2 into minus 4, why? Because we have made two operations, so minus 4 is added 2 times.